let us talk today about writing equations in slope-intercept form. And we did, you've probably done some of this before. Just as a reminder, if you've forgotten what slope-intercept form looks like, it's y equals mx plus b, where m is, of course, the slope, and b is the intercept, specifically the y-intercept. So if you have a slope and a y-intercept, like if I give you a slope of 2 and the y-intercept is 0, 3, then the slope-intercept form of that is just y equals 2x plus 3. Right? Yeah, simple. So today what I want to talk about is situations where they give you maybe something like a slope and a point. Maybe I tell you I want you to write an equation in slope-intercept form of a line that goes through the point 2, 3, and has slope of, let's make it 2/5. So a slope of 2/5, and we want the line to go through the point 2, 3. Now, a very long-winded way to do this is to graph it, because based on just a point and a slope, you can, of course, just go graph it. You can go over 2, up 3, put the point, and then use the slope to do rise over run up 2, over 1, 2, 3, 4, 5. The next point would be over here. You can plot your line and figure out the y-intercept. I do not recommend that method, but it is possible. You can do it. So there are two major ways to do this, and I'm going to show you both on this very simple example to start with. And I'm going to show you my favorite first. My favorite involves using a different formula for the equation of a line called the point slope formula. And the point slope formula looks like this. Y minus y1 equals m times x minus x1. The slope, and this is to be used with a slope m, and the point x1, y1, just being a point on the line. Now, you may see why I've chosen this, because we have been provided with precisely a slope and a point. So the point slope formula works wonders here. So let's put it into action. It's very, very straightforward. So you basically are just plugging this in. So this is, we'll let this be x1, y1 for our cases. This is, of course, m, the slope. So y minus 3 equals 2/5, the slope, times x minus 2. Okay, this isn't in slope-intercept form yet, because remember, we want it to look like y equals mx plus b. So we need to rearrange this. First thing I'm going to do is distribute that 2/5. So I end up with 2/5 x minus 4/5 by distributing the 2/5. Now I need to add 3 to both sides. Alright, so that leaves me with y equals 2/5 x. Negative 4/5 plus 3. 3 is 15/5. Is that accurate? Yes. 5/5 is 1, 3 is 15 of those. So 15 minus 4 leaves me with plus 11/5. So there we have our point slope form. And I think this is just spectacularly easy. This is the way that my math teacher taught me to do it at Montgomery High School, probably in the year 1996. And thank you, Miss James. She's still at it. It's just very, very easy. If you have a point and a slope, you use the point slope formula, plug it in, and it's very quick to get it into slope-intercept form. Okay, so this is my preferred method, and this is the method that I am going to mostly be using. Make sure to ask questions, by the way, if you have them, if any part of this process lost you somewhere. Okay, so now I'll show you the other method. Now, the other method is just going to involve using what we have on the screen so far. So we talked earlier about how if you know a point, or rather if you know a slope and a y-intercept, b, you can just plug into this equation and get the right answer. So what we can do is we can actually use this point and this slope to get b. And we do it by plugging into the slope-intercept formula, mx plus b. So what are we going to plug in? Well, we're going to plug in x and y and m. So we plug in, well, you know what, let's actually rearrange this first. Let's subtract mx from both sides. Subtract mx from both sides. So that's going to get me y minus mx equals b. So if we want b, we just need to plug into here. So plugging in y is 3, minus, our slope is 2/5, and our x is 2. So I plugged in for y, m, and x, and that gives me b. So I have some arithmetic to do here. Come over here. So 3 minus 4/5. Hey, that arithmetic looks a little bit familiar. 3 is, of course, 15/5, like we just talked about. Isn't that funny? It's not funny at all. We should get the same answer. So 15/5 minus 4/5 equals b, which gives us 11/5 for b, meaning that if we know m and we know b, we can just plug in y equals 2/5 x plus 11/5. I have met people who will swear to you on their grandmother's grave that this method, shown here, all of this, is faster and easier than the method I showed you to start with. I don't think there's a significant difference. I just personally like the other method better. I don't care which one you use, as long as you're showing your work, and if you need help, I can follow what you're doing. As long as you are clearly showing, I plugged in, I did the arithmetic, I got an answer, and then I plugged in again. All right? So that's pretty comprehensive for how to do ones where they give you a point and a slope. I recommend the point-slope formula, but you're welcome to use the method indicated here as well. All right. Another thing that can happen is instead of a point and a slope, they can sometimes just give you two different points. Maybe they give you 3, -1 and -2, 6. And they say, write the equation of a line that goes through those points in slope-intercept form. Well, neither method works right off the bat here, does it? Because a pretty integral part to being able to use the slope-intercept form is that we need to know slope. So the first thing we need to do, no matter what method you choose, in order to work this, is to find the slope. So the slope formula is, of course, y2 minus y1 over x2 minus x1. So let's label them so we don't get confused. x1, y1, x2, y2. Okay, so y2 is 6. 6 minus -1 over x2 is -2. -2 minus 3. Okay, so I get 6 plus 1 is 7. -2 minus -3 is -5. So I'm pretty comfortable with a slope of -7/5. Okay, let me double check that. Yes, okay. So now we have a slope, and we have 2 points. Amazing. Well, I recommend that we use my favorite friend, the point slope formula. And you may be asking yourself, well, how do I know which point to use? The answer is you can choose either one. It's like a party where you can choose which point you use, which is my favorite kind of party after all. I'm going to choose the first one arbitrarily because it's first. So plugging in my slope and my chosen point here, let us go. So y minus y1 is going to be -1 equals m -7/5 times x minus x1, which is 3. All right, y minus -1 is of course y plus 1 equals -7/5 x plus -3 times -7 gives you a positive. 3 times 7 is 21/5. I need to subtract 1. So I get y equals -7/5 x. 21/5 minus 1. Well, 1 is 5/5. 21 minus 5 is 16. So we have successfully written the equation of this line in slope-intercept form by using the point slope formula as our method to get there. I think a kind of a hidden benefit of using this form as opposed to the other method that I showed you is that it gets you used to plugging in for subscripts. It forces you to deal with some sign changes. It kind of makes you practice your algebra a little bit more. The other one is kind of just like more of a plugging in numbers sort of method, and that's fine. If you prefer it, please do use it. But I think that this one kind of has some benefits to going through the process. All right, I have one more idea I want to mention. The last thing I want to mention is the slopes of parallel and perpendicular lines. You'll be asked on a couple of the questions to write the equation of a line parallel to or perpendicular to another line through a certain point. So I'll just do an example to get started. So they'll say, I want your new line to go through the point 2, 7, and I want it to be parallel to the line y equals -1/2 plus 3. All right, there's a very simple idea about parallel and perpendicular lines. And that is that parallel lines have the same slope, and perpendicular lines have negative reciprocal slopes. So if we were going to work the problem here, where it says that we wanted a line parallel to this line, we'll simply, oh, forgot my x. If you saw that before now, good job. We'll simply harvest our slope here, m equals -1/2, because if we want a parallel line to this one, it needs to have the same slope. So if when we start our process of doing our work to write our equation, our slope will be -1/2 and our point will be 2, 7. All right, so that's for parallel. For perpendicular, we need to take the negative reciprocal of -1/2. Well, hopefully we all know what a reciprocal is. The reciprocal of -1/2 is -2/1, which is of course just -2. But the negative reciprocal of that would be -2, which would be 2. So if we wanted a perpendicular line, we would use m equals 2 and the point 2, 7. A bit more on negative reciprocals. If I have the number 3, the negative reciprocal is negative 1/3. If I have the number 2/7, the negative reciprocal is negative 7/2. If I have the number negative 3/5, the negative reciprocal is positive 5/3, and so forth. Well, and if I have the number 1/2, the negative reciprocal is negative 2. Okay, so that's how you determine what slope to use if you're looking for a perpendicular line through a point. So that should be enough for this lesson anyhow. Make sure you're asking questions as you have them.